Welcome, young students of chemistry. This is a short recording about how to look at a tool, determine the scale, and therefore the known and estimated digits that you will need to record when you are making a measurement. So first thing I want to just tell you, we do go over this in class, so this is just if you need a little bit more, you need to hear it again. Whenever you have a measurement, so if we have a measurement like this, 2.040 centimeters. This tells us something. The last digit that is recorded is always an estimated digit. And then the digit before that is a known digit. The known value is the scale of the tool. So by looking at this number, we know something about the tool that was used to make this measurement. We know that this tool has a mark for every, let's see, this is the ones place, this is the 1/10th, this is the 1/100th. So this tool has a mark for every 1/100th of a centimeter. So the number of decimal places that you record in a measurement is extremely important because it's telling us about the quality of the tools that we're using. So if we're looking at this graduated cylinder here, this is the one from your drawer. This is a little confusing. Try to ignore these straight lines. That's where the line is circling the graduated cylinder. But if we look at this, to determine the scale of the tool, we're going to just pick two numbers that are marked. So I have a 40 here. This is the line for 40. And I'm going to go up here to the line for 50. And I'm going to count the number of lines that are between 40 and 50. So to determine the scale, I'm going to pick two numbers that are marked, and I picked 50 and 40, and I'm going to get the range of those numbers, so I'm going to subtract. And then I'm going to count the number of lines. So I've got 1, 2, 3, this one, oops, I better come over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So there are 10 lines between 40 and 50. So if I take 50 minus 40, that gives me 10. Divided by 10 gives me the scale of this tool, which is 1 unit. This is a graduated cylinder, and it's measuring in milliliters. So when we make a measurement using this, the known digit is the ones place. The estimated digit is the 1/10th place. So any measurement that's made with this tool must have a 1/10th place recorded. So let's measure the amount of liquid that's in this graduated cylinder. This is not the best picture, but it does work. We can see that there are more than 50 milliliters here, but there are less than 60 milliliters here. So in using that, we know that each mark represents 1. Well, this is a nice little reminder that this is 55. So we know it's 55, 56, 57, 58. This amount of liquid, using the bottom of the meniscus here, is somewhere between 59 and 60 milliliters. So how do we record that? We know that it is 59. 9 is our known digit. And then somewhere in between is an estimate. I'm going to say it's 59.8 milliliters. The tens place must be correct. The ones place must be correct because that is the scale of the tool. The number that is here in our estimated place, the 8, it doesn't really matter what that number is. This could be anywhere from a 0 to a 9. And that's really an acceptable answer in terms of indicating the precision of the tool or the accuracy of the tool. However, when you're measuring, it's best to get the best measurement that you can get. So you should be as accurate as you can be with your estimated digit. Let's look at another tool. This is a meter stick, and we can see that if we want to determine the scale of this meter stick, let's see what color is going to go. We're going to look between two numbers. I'm going to use the 3 and the 4. So 4 minus 3 divided by the number of lines between them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 minus 3 is 1. 1 divided by 10 is 0.1. So this is the scale, and therefore the known value in your measurement. Remember that we always have to record the known value and one more place to the right of that, which is our estimated digit. So if we're making a measurement like this, let's say we have something that's falling right in between here. This is going to be 6 centimeters. We know that each mark is a 0.1, so this is 6.1, 0.2, 0.3, 0.4. So this is 6.4, and it's not quite 6.5, so it's going to be something in the middle of 6.4 and 6.5. I'm going to pick a 3. Doesn't really matter there. So what I have done is recorded the scale of the tool, which is the known digit, and I have recorded one more decimal place to the right of that, which is an estimated digit. Every time you make a measurement in honors chemistry, you must make your measurements properly. I'm going to be looking at your tool and looking for a known and an estimated digit. One more with you here, and then we're going to end this. So this is a little bit different. Here we have a ruler, a graduated cylinder. It goes between 190 and 210. So if we want our scale here, 210 minus 190, and divide by the number of lines that are between 190 and 210. So here's the 190 line. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 210 minus 190 is 20. 20 divided by 10 is 2. So this gets a little bit tricky because although 2 is a number that is in the ones placeholder, right? This graduated cylinder does not have a mark for every one. So we have to be really careful with this. We cannot say that this may be the scale of the tool, but this is not the known value of our measurement. Our known digits, because we don't have a mark for every single one, the 2 is in the ones place on a placeholder, and because we don't have a mark for every one, we cannot say that the known value is 1 milliliter. So really we go back to the thing that we do know, and what we do know is the tens place. We know that this has a mark for every 10 milliliters. So what we're going to do when we make this recording, let's go ahead and make this measurement. We see that here's the meniscus right here. It is somewhere, there's 210, 211, 212, 213, 214. Here's 215. So it's somewhere in between I'm sorry, I've got that wrong. The scale is 2. So here's 210, 212, 214, 216, 218, 210, 211, no, 210, 212, 214, 16, 18, 220. So it's somewhere between 220 and 222. So our estimated digit here, we know that it's 200. As a matter of fact, we know that it's 220 something, and we know that it is smaller than 222. So this is going to be our estimated digit, the ones place. If it's smaller than 222, we can say, hey, it's 221, it's 226, it's 223. It really doesn't matter what's here, but this is our estimated digit. So just be careful that when you get a scale, and really what you'll see is that sometimes you'll get 2s, or you'll get 0.5s, or you might even get 10s. The scale is, well, no, that works. But normally if you get 0.2s and 0.5s, you have to be careful because these are not ones. If it was a 1 fine. If this 0.5 was a 0.1, that would be the known value in your measurement. But because 2 is not a placeholder in a number line, and 0.5 is also not a placeholder, the tool isn't really as accurate as this number would believe us to be. These 0.5s and 2s, they're just here to help us make a better estimate, that's all. So this graduated cylinder, the known value is the tens place, the estimated value is the ones place. So even if you think it's exactly 223 milliliters, you may not write 223.0 because now you've changed the tool. So just be careful with those 2s and those 0.5s. Okay, hope this helps.